How was your test last night? Is it okay, right?
I hope it's okay.
All we have done in class, right?
Yes.
Nothing new. All we have done, we have covered everything. I'm glad to hear that if you comment is like that. Some of you just it's not no, just forget. Yeah. Okay. So we finished the test. So we only have 30 students now. What happened to the rest? Wait 1 more minute, can we?
Can.
I haven't read the question about the thick cylinder. What the question about? What is the question about? What is the boundary condition?
The boundary condition is QH in the middle. QH pula, what did I say? The sigma H in the middle given.
So use it as the boundary condition. See that? Sigma H not in the outside or outside, right? So we have that one, what is sigma? It's given that one, right?
Yes, given equals to 150.
Sigma H at that point B, the one that's A, that's B, C there. At point B is equal to 100, right? 100.
150.
150. So how to write that one? The one is, let's say this is 0.1, this is 0.15, so this is 0.2, so 1.5 that one. So what's that? A plus B over 0.15 square is equal to 150. The other one is that the pressure inside or outside?
Pressure outside.
Pressure outside is what?
10 megapascal.
Pressure outside 10. So how do you write that one? The other one is sigma R is equal to A minus B over R square. So what is the equation there?
Negative 10.
A minus B 0.2 square is equal to minus 10. So those are the equations that you have to solve. Those are the boundary condition. So we have to decide. Decision making. It's all about decision making. Okay, let us start our session today with a moment of silence first and remembrance of our God, our Father. Why we have to thankful to God every single time? Why is that?
Give us the akal.
The output is akal. But what we have to run that akal, that Allah give His component to us. What is that? We can see. We can hear. See that? We can hear things, we can see things. We can read and write whatever it is. And then we have the energy in ourselves called kudrat. Energy, the capability to hold, to write that one. You don't have energy, can we write?
Cannot.
We have the urge. I want to write that one. If I want to write that one, but I can write. I have the kudrat. I have the energy. But I don't want to write. So the written, that one can be written not? Cannot. The urge. Energy. And then you have the ilmu. You have the ilmu. And then you are alive. All that belong to God. You have the energy, you have the urge, you have the ilmu, and then you are alive. If you are dead, you cannot write. Are you with me?
Yes.
So all that belong to the alive thing. It's all from God. It's all from God. That's why we have to. That one will give you the intelligence. That one will give you extra. That one will give the akal. That one will give you CPU. That one. That's why we have to think. Even we don't do anything also, we sit down only. Sit down. You know how to sit on the chair. That means you have the ilmu. The ilmu is also from God. You have the urge to sit on the chair. That urge is also from God. You can eat the rice. You have the urge to eat. If the urge is not given to you, you go to hospital, I don't feel to eat lah. Apa? Tak ada selera lah. Selera dia one also from God. Are you with me, guys?
Yes.
That's why we have to be thankful every single time. Not talking about higher level. Even the basic level that we are done, we can walk, we can talk, we can see, we can hear, we can write, whatever it is. We can cook. The energy, or the 7. That's what they call the 7 habit, the 7 creature, the 7 level, the 7 whatever it is. Those are the God-given capability. Okay, never mind. Today let's continue with the energy theory. What is the Castigliano theory last time?
Differentiate U to P. Give us the deflection.
Okay. Differentiate to moment, we got the slope. Differentiate to load, we got the deflection. We got the deflection. See that? But the U cannot be put in numbers. The U must be put in same symbol. The load P, we cannot put the P 100 there. Put symbol P or Q or R. Or put the symbol is Q, so du per dq. So we have two-step method there. The first Castigliano theorem is two-step method. What is that? We have to find the energy first, right?
Yes.
Are you with me?
Total.
And then we differentiate. The energy. But the energy must in terms of symbol. Symbol of the load. Correct me?
Yes.
Today we are going to use a direct method. But we have to understand the theory first. Are you with me, guys?
Yes.
We don't use two-step method. Two-step method is what? You have to find the energy first and then you find the deflection. 2 times. The second, today is second Castigliano theorem. This second Castigliano theorem is being developed not by Castigliano, by his student. Okay, by his student a long time ago. The first Castigliano theorem, that's that one. Energy, and then they differentiate the energy, we got deflection. But his student make a study how to simplify it. Yeah? See that? Energy, let's say we have that one. Energy is equal to, let's say by bending moment. Moment square dx over 2ei. Right? And then from the energy, We got a delta equal to du per dp. Let's say energy moment is px, that one, like that one. Okay? So cut there. So p and then distance there, x there, p there. So my moment is equal to px. Put it there. Are you with me, guys?
Yes.
But I never put the p in numbers. So we can solve it. Let us do that. Let us do that as usual. Okay? To do that as usual, so what is that? What is my moment? Px, right? Square, we got p square x square, right? And the x, let's say 0 into 2 there, and then 2 ei there. So what do we have there? Integrate this one, we'll get p square x cube over 3 at the bottom, 3 times 2, 6 ei, right? 0 until 2. So those are the energy, right?
Yes.
Yeah. So put the value 2 there. We don't touch p because we want to differentiate the p later on. Don't touch p. Touch x only here. 2 times 3, 8. This is equal to 8 over 6 p square over ei. Those are the energy, right? And then we differentiate du per dp. What do we have there? Differentiate it. What do we have there? 8 over 6 p square, we got 2p, right?
Yes.
Over ei. So what do we have there? 16 over 6 p over ei. And then we put the value of p. And then you got the deflection. That is delta. So remember that? 16 over 6 over p over ei. Are you with me, guys?
Yes.
For this case, the deflection is 16 over 6 p over ei. So this is my first Castigliano theorem. Today we want to go into second Castigliano theorem. What are the second Castigliano theorem? Look at it. It's all by mathematics. See that? If a delta is equal to du per dp, I understand inside that one have energy from moment. For this case, moment only, right? It's no torsion, right?
Yes.
So, can I write this one? du per dm times dm per dp. Can I write that one? Simple
Can.
mathematics.
Can.
Is that true?
Yes.
So, I got the m. I got du per dm. What is the u? U is equal to that one. U is equal to, so write down properly there. U is equal to m square dx 2ei, right? So what is du per dm? Just play around with this. So du per dm is equal to what? Integration, just leave it there. What do we have here? Now we're talking not m, not x, dm. U over dm. What do we have?
2m.
Please respond. Hello?
2m.
Yes, 2m. Then the other one is constant dx. The bottom one is 2ei. That's it. Are you with me, guys?
Yes.
And then I go back to here. What is my m? My m is equal to px, right?
Yes.
And then I go to my second one. What is dm dp? Dm times dp. What is dm? M is here. What is dm dp?
X.
X. So what do I write there? So just what do I write there? Delta here. So delta here, write down back properly there. So delta is equal to du per dm is equal to that one, right? 2m. 2 and 2 cancel out. We got m over ei, right? And then dx, right? Are you with me?
Yes.
And then times dm per dp. Times dm per dp. So this is x. Just leave the one for a while. Just Just write down that properly. Write down properly. Can I write that one in the middle there? That m times dm per dp integrate to x. So this is one entity. This is one entity. So this one entity there. So dm over dp just new name one entity. Are you with me?
Yes.
The 2 and 2 cancel out. So the deflation now become very simple. Deflation is m times dm over dp integrate into dx over ei. The 2 is cancelled out already over ei. So this is just a simple equation. Integrating the energy and the dm per dp. We got a simple equation. We got straightforward deflation. M times dm over dp. M times dm over dp. If the load is q, m, if the load name is q there, so this is dm over dq. Integrated into one equation. Are you with me?
Yes.
Okay, very simple. And then let us do that. Check it. Is that correct or not? Yeah, put there. The deflation there was delta P there. Delta P must be M times dm over dp. dm over dp is one entity. Remember that? dm over dp, one entity. And then integrate that into dx. And the bottom one is ei. So I draw this one. What is my m? My m is px, right? My m is px. Integrate that. From 0 until 2, 0 until 2. So dm over dp, truth, I got this one. M equal to px, dm over dp is x. Straightforward, right?
Yes.
So dm over dp is x. And then integrate into dx. The bottom one is ei. So this one become what? Px squared dx over ei. Are you with me now?
Yes.
And then P over x squared, integrate what we have? Px cube over
3.
3ei. Correct?
Yes.
0 until 2. So what do we have there?
8.
What do we have there? 2 to the power of 3 is 8, right? 8 over 3 PEI. Just now what do we have?
It's the same.
Just now we got what? 16 over 6. P over EI, right? This divided by 2, we got 8. This divided by 2, we got 3. The same, not?
Yes.
This is straightforward method. And this is two step. This is one step. Because become a new equation. The new equation just become deflation equation. So this is what we call second Castigliano theorem. But it's derived from first Castigliano theorem. Nothing more. It's the same. Both are called Castigliano theorem. Are you with me, guys?
Yes.
Easy not? Easy not?
Yes. Easy.
Very easy. So if you know the energy is from torsion, so how you got the deflation then? Same thing. Energy from torsion, and U is T square, right? dx over 2gj, right?
Yes.
So deflation is what? du over dt times dt over dp, right?
Yes.
So if I differentiate this one into t, what do we have there? What is du? What is du over dt? The same thing, not? We got 2t dx over 2dj, right? Cancel out. And then time dt over dx. So the new equation become what? Delta is equal to t times dt over dp, right?
Yes.
And the bottom one still the governance body, gj, ei, ea. Are you with me? The two cancel out. I integrate into dx. Are you with me?
Yes.
Very simple. So we just have to find the equation for t, equation for m, and then differentiate that equation into the load that you are using. We have done that for the simple one. We have done that for a simple one, that one. Let's look at the 3D, that one. This one, we got torsion. Let's say name Q now. The name is 100 Newton. So I don't want 100, I put Q there. So this is 2 meter, this 3 meter. From A to B, B to C. I want to do straightforward because, see that? You must visualize this one. When I push this one is bending, not?
Yes, bending.
This one is bending down, not? This one is bending down. When this is bending down, this one go down, not?
Yes.
Automatic go down. So this one is bending. This one is bending, go down. And then this one is twisting. This is torsion, right? 100 times 2 along here have torsion, right? This one don't have torsion. This one have torsion, not?
Got.
Yeah, this one have torsion. Torsion, what happened? When we have a torsion like that, when I twist this one, what happened? See that? This is beam here, just stay there. But this one I twist. This one, what happened? This is one, rotate, but this one go down, not?
Yes, go down.
So when this one is rotating here, this one automatically go down here. This one don't go down, still there, but the other side will go down, right?
Yes.
So from here to here is delta due to BC bending. See that? Point A here go down there, due to this one go down bending. This one also go down, right? And then BC torsion is twisting. This one also go down, but due to BC torsion, right?
Yes.
And then the other one, this one is also bending. So this one also go down, not? This is due to AB bending. So this total deflection here, see that? Delta at A there, delta at A here depend on bending of AB. Must be delta through bending of AB, correct?
Yes.
And then must also due to the bending of BC also go down. Bending of bending of AB, point A. Bending of A due to BC, this is bending moment. This is also bending moment, but rod BC, right? And then there's another due to torsion, rod BC, correct? Can you imagine that one now?
Yes, can.
This one is the total deflection then. So can I find it through, we have done the energy just now. Energy here have torsion, energy here have bending and torsion. Here have bending only, correct?
Yes.
Okay. So what do we do? Do that by direct method. Second Castigliano theorem. So, what are that one? The most important thing one is cut section. From A to B, cut section there. Cut section, we got a diagram like that. So this is Q, this is my X, this is my moment, right? So my moment is equal to QX. Are you with me?
Yes.
This is from A to B. The general cut from A to B, cut somewhere there, you name the distance X from A. And then you cut from B to C, cut from B to C there. So there's a Q here, the Q. The distance now is 2. Now, that distance here to here, call it X. That is my X. There's axis there. So, my X is from B to C. I'm cutting from B to C. This is from B to C. So, there is a moment there. Moment is equal to QX. Q times that distance is rotating about that axis, correct? Free body diagram. And then the Q times 2 is rotating about that axis. So this is the reaction. Torsion is equal to 2Q. Correct?
Yes.
Now I have energy from 2. T and moment. Here we have a moment only. Are you with me, guys?
Yes.
It all start with cut section and proper free body diagram. can you write the proper equation for T and proper equation for M? M. You know that it's M there, what's the equation there? You know the M there, what's the equation there? You know the T there, what's the equation there? Are you with me?
Yes.
And then, you know that one. So, I know that my imagination just now, deflection at A, is all depend on that deflection, and then that torsion here also go down there. That is that one. So, I got delta and A. How to solve that one? AB. Mass moment from AB. Bending moment. The moment is what? M dm dq over EI. Are you with me?
Yes.
Energy that direct method is M dm dq and integrate into dx. And then from B to C, there's a moment and torsion. So there's another one BC there. But the moment one is M here, then M here. M dm dq also over EI, dx. But from B to C. And then the other torsion is T dt over dq over GJ. From B to C. Are you with me, guys?
Yes.
Okay. And then write down that. From A to B, from 0 to 2, 0 to 2. Your M is, go to back. That is QX. What is dm dq? Go back here. dm dq is equal to X. Am I correct?
Yes.
So I got X there, and then dx. And then over EI. Finish one. What is the other one here? From B to C. B to C, 0 to 3. 0 and 3. My moment is here. Not this moment, But still X there. Q times X. So Q times X. And then dm dq is equal to X also. Right?
Yes.
So put it X also there. And then integrate into dx. And then 2EI there. And then GJ here, can I write this one? So plus, what is the T there? The T is 2Q, right?
Yes, put you.
2Q. Yeah? What is dt over dq? So you write down just now T is Q. Like appropriate. T is 2Q. What is dt over dq?
2.
2. So here we only have 2 there. Not X. So dx is still dx there. And then gj is still gj, but 0 until 3. Because the line is 0 until 3. Are you with me?
Yes.
So the same. So we do that. What do we have there? Qx squared. Integrate. We have Q at cube, right? Qx cube over 3EI, right?
Yes.
0 until 2. So what do we have there? Qx squared. What do we have? Qx cube over 3EI also. But 0 until 3, right? A to B is 2 meter. B to C is 3 meter.
Yes.
And then what do we have there? 2Q times 2 is 4Q, right?
Yes.
4Q is nothing to do with X. So what do we have? 4QX over J from 0 until 3. Are you with me? Very simple. So what do we have there? So we have 2 over 3, 8. 8 over 3, right? 8 over 3 Q over EI. And then plus 3 times 3 what? 27. 27 divided by 3 is equal to?
9.
9. 9, right? 9Q over EI. Or you can write 27 over 3. 3 and 3 there. The 27 plus 8, you got 30 something. Okay, plus, what do we have here? 4 times 3 is 12. 12Q over J. So, this is exactly the same as what we have done in the previous homework, right?
Yes.
So we can do that second Castigliano theorem by doing what just now? Direct method. M dm dq or M dm dp depend on what is the load. If you put the symbol of the load is P dm dp lah. Symbol of the Q dm dq lah. Are you with me, guys?
Yes.
Kalau ada T, dt over dq lah. T times dt over dq. So this is direct method. Direct method memang energy and differential do it together become that equation. Or you don't want to understand the theory, just remember that theory. Remember the formula also can. That's why I don't like to remember, because you don't understand what the hell is that. You know how to derive that one, right?
Yes.
Start from energy. Energy, what's the energy? M square. Integrate that one. T square, integrate that one. Q and V, P is very small, don't neglect it. For that energy purpose here, the P energy from axial and shear we neglect. Very, very small. Only from torsion and moment. So just to remember, M dm dq and T dt M dm dp, or call it P, and the other one is P. If the load is symbol P. I just purposely put the Q there because you just don't remember P every time. Can be F. Can be whatever symbol, as long as it's the point loading. Okay, clear, guys?
Yes, clear.
Very clear. So this is what I call second Castigliano theorem. On that load, what's the energy? How do you know energy? You do Castigliano. When the Castigliano there is M, so there must be energy from M. When the Castigliano there is T, there must be energy from T. Very simple, right?
Yes.
Okay. Let's continue with the last one. Okay. Can I continue with the last one topic? Not new topic, but still energy theory here. There's one called dummy load. So we'll take quite a long time today. Can we? Because we have only next week to finish one more topics. Okay, can we? Can we continue?
Yes. Can.
Yeah. So this topic about this second Castigliano theorem is finished. I give you homework later on, and there's another topic called dummy load. Yeah? The last topic is called dummy load. What's called dummy? What's the meaning of dummy?
Stupid.
Huh? No. Dummy is tipu. Okay? Tipu lah. Load is load. Mana daya tipu. Are you with me? Daya
Yes.
tipu. Bukan, not real lah. Tipu. Okay, look at this. What's the meaning of that one? Delta P is equal to du per dp. Understand that one? What do we recall last time? Deflection at
P. At the direction of P.
deflection at P, right?
In the direction of P.
Deflection at P. Now look at this. I have a P here, so I can find the deflection here, not? Yes, because in the direction of P at P, right? What if I want to find the deflection here? It's point A. There's no load here. I want to find the deflection at A there. There is a deflection, right?
Yes.
But this theory cannot solve because I don't have load there. Are you with me?
Yes.
So what do we do? I want to find deflection there. But the theory Castigliano says, I want to find deflection there. There must be a load there. So I still follow the Castigliano say. I put a load there, name Q, but the value is 0. Dummy not?
Yes.
The value 0 means just P, only P, I have 100 Newton there. Q is nothing there. But if I put that, I want to find deflection there. Can I put that DQ there? Can I find the deflection at B there? Delta B. Can I put that?
Yes.
This is still valid because differentiate into load there, even though the load is 0. This is a nice thing. This is what I call dummy. This one going down due to that P push down here, so this is deflection, right? So this must be have deflection there. But not due to that Q, due to that P, right?
Yes.
So, but Castigliano say, if I want to find deflection there, I need to have a load there. So I still follow that. I put a Q there. And the value is 0. Just dummy. This is the meaning of dummy. This is the use of dummy. If I want to find a deflection somewhere here, what is deflection there? Put a dummy load there. F equal to 0. And then we do the process. Clear, guys?
Yes, clear.
Now you understand why they call it dummy?
Yes.
Dummy. Yeah, let's do this one. Let's do this one. Yeah. So this put a load there. This is P is equal to 100 Newton just now. So I want in the middle here. I want to find A there and B there, C there. So if I put that one, the diagram will surely sit like this, right? So this is deflection of A. This must be deflection of B, right? So this 1 meter, this 1 meter, that's all. So I put a dummy load there. I put a dummy load. Q is equal to 0 there. From A to B, B to C. So how many sections now I have? 2 sections. Just now, just 1 section from 0 and 2, right? Now we have 2 sections. Cut it there. Cut it there from A to B. Cut between A and B. The title. Do a proper free body diagram there. So we have a P there. So this is my X. My moment there. My moment is equal to PX. DMDP is equal to X. Now, cut between, so I don't want to cut here, I want to write equation there. Cut between B and C. B and C there. Cut there, what do I have? Draw the whole diagram. This is P. So this is Q. This is my X. This is 1. Are you with me that?
Yes.
So this your X between B and C. You cut between B and C there. C is there, not C. Between. Not cut at C, no? Cut somewhere there. This is what I cut there. X is 0 from C. So what is the moment there? My moment is equal to what?
P plus QX. P 1 plus X
And then?
plus QX.
So here, can I write what is the MDP? What is the MDP?
And 1 plus X.
1 plus X. What is the MDQ?
Q. X.
The MDQ.
X.
X, right? I got all the input there. Now, energy from AB, energy from BC, right? Energy from AB belong to moment, right?
Yes.
BC also moment, right? No torsion there, right?
No torsion.
The moment equation is there. The moment equation is there. Are you with me?
Yes.
So now I write, I want to find deflection at B. Must be integration AB, moment. If the moment was the equation, M.
DMDP.
Not the P. I want to find at B now, not at A.
Oh. DQ.
What is the load? What is the load at B?
Q.
Q. Be careful, Must be the load at B. At B, the name of the load is Q. So over EI. And then DX. And then the other one, integration from P to C. What is the equation M?
MDQ.
Yes, MDQ, but that M belong to that M. That M belong to that M. Are you with me?
Yes.
Different M here. The MDQ different, the EI. Integrate into the X. So you have AB here, the M is equal to PX. The MDP is equal to X. Now I just by mathematics here. I don't have any Q here. What is the MDQ? Here. So what to answer?
0.
0. Be confident. There's no M, there's no Q there. So the MDQ is what? 0. Are you with me, guys?
Yes.
You must be very confident. So now, from A to B, the moment is that one. Moment is what? Px, right?
Yes.
The moment is from 0 to 1. A to B, 0 to 1. The moment is Px. What is the MDQ? Read here. What is the MDQ? 0. Integrate dx over EI. So the whole thing times 0 becomes 0, right? And then, what is the second one here? From BC here, from B to C, also from 0 to 1, 0 until 1, right? What is the M there? Read M there. What is the M?
P1 plus X plus QX.
1 plus X plus QX. You know what is the value of Q?
0.
What is the value of Q?
0.
0. No problem. 0. But it's still, moment is there. Are you with me? And then what is DMDQ?
X.
X. X there. And then integrate into the X there. So even though this is 0, that X times this one still have value, right?
Yes.
So what do we have then? P times 1, X there. Px times 1. Px times 1. You got Px, right? Px times X plus Px square, right?
Yes.
So you elaborate this one, you got this one. And then you integrate it. You haven't integrated yet. And then over EI. So what do we have there? Integrate this one, what do we have?
1 over 2 px squared.
Yeah, Px square over 2EI. From 0 until 1. And then the second one, what do we have? P
1 third of px cube.
Px cube over 3EI, right? 0 until 1, right?
Yes.
So, we got value not? Yes. What is the value there? So, 1 there, what do we have there? P1. The P over 2EI. 1 square 1. And then where we have here? 1 to the power of 3 is 1. The P over 3EI. So, P over 2EI plus P over 3EI. Those are the deflection at point P. So, if I write down that properly, what's the value there? How can I write that one very nicely? 1 over 2 times 1 plus 1 over 3. What's the value there?
5 over 6.
0.5 times 0.33. What's the value? Plus 1 over 2 is 0.5, right? 1 over 3 is 0.33, right?
1 over 3, 0.33. Yes.
So the total value there is what?
0.83.
33 P over EI, right?
Yes.
Are you with me?
Yes.
Just leave P over EI there, 0.833 there. That's the deflation there. So the deflation here must be higher, right?
Yes.
So we have done that before. So we can do that very quickly. You want to find an A. If I want to find an A, I don't have to write the Q, right?
Yes.
Very quick that one. So I want to find that A, what is the value at A? We have done it so many times. What is deflation at A, that one? Deflation is a moment is equal to Px, right? Cut it there, we got a moment on.
Yes.
So dMdP is equal to X. So integrate from 0 until 2, 0 until 2, M dMdP. My M is Px, the MdP is X, right? Integrate dx over EI, but not 0 to 1, 0 until 2. Yeah. So deflection at E. So what is the value there? Px cubed over 3ei from 0 until 2. So what do we have there?
8 over 3.
8 over 3 P over ei. So what is the value 8 over 3?
6, 7.
2.67 P over ei. So this is 2.67. This is 0.833. So common sense not?
Yes, common sense.
So correct lah. This is 2.66. The other thing is just constant P over ei. 2.66. This one is 0.83. Common sense. This is much less than this. So that is dummy. Are you with me?
Yes.
That is dummy. We don't have any load there. I want to find the deflection there. What do? Put a dummy. When I put a dummy, so it's not one section anymore. 2 section, right?
Yes.
A, B, B, C. It's not 1 section anymore. 2 section. So what if I want to find the slope here? When I put a load there, P there. So this one have slope not?
Yes.
So if I want to find a slope, I have to differentiate into moment. Remember that? du per dm. We got a slope. du per dp, we got a deflection, right?
Yes.
So I have to have a moment there. Now I don't have a moment here. What do I put? I put a dummy moment there. Can I put a dummy moment there?
Good.
Yeah, put a dummy moment there. The value is 0. Just for the sake of I want to find the deflection at that point. So, can I do that? Yes, no problem. From the beginning, not from afterward. From the beginning, I want to find a slope there. Slope means dy dx. Theta is what? Dy dx slope. This is slope there. See that? Slope, this is dy, this is dx. Dy over dx is the slope theta here. Are you with me, guys?
Yes.
Tangent theta, that one. Slope. So that means theta is the slope. So what is the slope? Is theta dy dx. So how do I find dy dx there? So theta is equal to, remember that? Theta is equal to m. Sorry. The energy is m. Must be m dm over dm dot, right?
Yes.
Over E I. Because differentiate into m dot, even though the m dot is dummy. So cut it there. Put equation there. There's a dummy moment there. There's a P, the real one is a P there, 100 Newton. The m dot is 0. So what is my x there? What is my moment equation? What is my moment equation there?
Px
Px
plus m dot.
Plus m dot. I know my m dot is 0, right?
Yes.
But what is dm per dp here?
X.
What is dm per dm dot?
0.
No, there's m dot there.
1.
1. So, you got a value here or not?
Yes, got.
That's the nice thing. My moment is that one. Px plus m dot. Even though m dot is 0, no problem. But dm over dm dot, we got value there. See that?
Yes.
And then integrate into dx over ei. So we got, even though this is 0, no problem. Px times 1, px. Integrate it, we got what? Px square over 2e I. 0 until 2. You got value not? We got 4 times 2 divided by 2 is 2. 2p over ei. What is that? That is dy dx. Slope of that one. Is that?
Yes.
Remember that? Differentiate into, start with the formula that one. theta is equal to du per dm dot. That one is what? Du per dm times dm per dm dot. Are you with me? You got that
Yes.
equation. So you got a straightforward equation. Same like du per dp, sorry, du per dm, dm per dp. So we got a delta there. So this one we got dm per dp, we got a deflection. dm per dm dot, we got a slope. Even though the m is dummy, the dummy must be 0, put 0. If the q is 0, put 0 value. Are you with me, guys?
Yes.
Very easy, not? The concept of this dummy. You want to find at other point where there's no point load there. I want to find deflection there. So what do? Put a dummy load. I want to find a slope there. There is no moment there. Put a dummy moment there. Clear, guys?
Yes, clear.
Yeah? So, what about this one? Look at this. What about this one? We know this one. This one will go down there, and then we should go down there, right?
Yes.
This one will go down due to what? Due to the bending. And then torsion here, this one will go down. Torsion. And then this one will go down. Bending here will go down. And then this one bending will go down. This one torsion, this one will go down straight. Right? So 3 different here. So every point there's a deflection, not?
Yes, got.
Because this go down to that point. Then it go down to that point, right? So
Yes.
every point that got deflection. Every point there is a deflection. Here the deflection is there. Here the deflection is there. Is it that? Is it that?
Yes.
So if I just put a load there, P is equal to 100 Newton, can I find a deflection there? A, B, C. I don't want to find at A, B, C. I want to find at F here. Can I find a deflection there? How much there?
Yes, can.
Yes. So what do we do? Put a
load.
dummy moment, dummy force F there. So when you put the dummy force there, how many sections you have to cut now?
3.
1, 2, 3. Are you with me?
Yes.
If the question is there, I want to find the slope at B. This one the slope. Go down the slope now. Slope, right? So I have to find a slope there. What do I have to put there? I have to put a dummy
Slope, dummy moment.
dummy moment. So I have to put dummy moment there. So when I cut here, there's no including dummy moment. When I cut there, so about that axis, so I put a dummy moment there, m dot is equal to 0 there. And then I want to find that moment there. So that is your x, that is your p. Is it right? A dummy moment?
Yes.
Because I want to find the slope there. So these are the equation. 2 distance there, x there. So my moment is equal to what there? P times x plus m dot, right?
Yes.
dm over dp, you got x. dm over dm dot, we got 1. So I can find that and then but the integration, the slope theta at b here, mass integration a to b, mass plus integration from b to c, plus integration, a to b, b to c, 2 only. A to B as only moment. This one become 2 because this from moment and the other one from torsion, right? B to C. Are you with me?
Yes.
Energy is from torsion and moment. So the 2 integration must be there. Are you with me, guys?
Yes.
So what are the equation there? This must be, I want to find a theta at B. This must be done from the beginning. So what do I have in AB? AB is moment only. There's no torsion, right?
Yes.
Moment, dm over dm dot. And you know that when I cut here, when I cut there, my moment is P, and then the moment is equal to Px. dm over dm dot is equal to 0, right? There's no m dot there because m dot is here, right? I cut here, m dot does not exist on A to B, right?
Yes.
So dm over dm dot is what?
0.
0. So I know this is 0. This one. But from B to C, my moment, I got the equation moment there. And dm over dm dot, we got not. Got a value there. Are you with me?
Yes.
And the torsion part, from B to C, I got a torsion not? Yes, torsion is 2 times P, right?
Yes.
Cut it there, torque is 2P, right? What is dt over dm dot?
0.
There's no m dot there. What's the value? 0. So this must be times 0 also. Are you with me?
Yes.
The process is still the same. And then you fill up and then you know this is 0, this is 0. This one got value. You can find the slope there. Even though it's dummy. Are you with me, guys?
Yes.
Very clear. So that's the concept of dummy. Okay, two things that we learned today. The first one is the second Castigliano theorem. The end formula is what? Delta is equal to m times dm dp. Integration of m times dm dp over ei. Right?
Yes.
Or dm over dm dq. Okay? If you want to find a different point. If you're a dummy f, m times dm df. You got a straight for deflection. For slope, theta is equal to m times dm dot. Even though the m dot is 0, put a dummy m dot. Find deflection, put a dummy load. Find the slope, put a dummy moment. If that point don't have moment. That one P, I want to find deflection there. So I cannot put dummy there because already P there. I want to find here, put a dummy. Because there's no load there. Very clear, right?
Yes, clear.
Okay, two things that we learned today, yeah? Second Castigliano and dummy moment, dummy load. Title is dummy load just now, right? Okay, I give you some exercise. Okay, thank you very much. See you again next week.
Thank you so much, Doctor.